hypothesis testing to compare two mean of two different populations. Now, in this case, we want to compare two population means and then find out if they are equal, if one of population is greater than the other, or one population is less than the other. Now, let's take a look to our problem. We want to test here if the calories for fruit punch and lemonade are equal or not equal. So the steps are very similar. First step is to set up our hypothesis. Here, H0 mu population for fruit punch equal mu population to lemonade, and H1 mu fruit punch is not equal to mu lemonade. So make sure mu r stands for population mean and x bar is for sample mean. Now, in order to find or in order to test our hypothesis, the second step after we find out the hypothesis, the second step will be to find the critical value. We need to use the t-test because the population variances are unknown but assumed equal. So we need to use t-test. Remember, we use t-test if population variance is not known. So in this case, in order to find the critical value, we need to use again the function t.inv.2t. So let me put here. As you can see here, we are using t.inv.2t as we used in the previous chapters. Now the probability is B5, which is our alpha, 0.03, and degree of freedom is a little different here. Degree of freedom equals n1 plus n2 minus 2. So n1 is sample size 1 and n2 is sample size 2. So there are 13 samples plus 11, 24, minus 2, 22. So B16, as you can see here, B16 is 22. So degree of freedom n1 plus n2 minus 2. So once I enter this data and hit OK, so I find lower critical value is minus 2.32 and upper critical value plus 2.32 for 3% alpha. For alpha 3%. Let me just copy and paste the graphic here. So now I know the critical values. The next step, remember, for the hypothesis testing is to find the test value for t-statistics, and if the test value is between these two numbers, I will accept H0. If the test value is outside this range, I will say H0 reject, H1 accept. So the way we find the t-test or the t-value is from this formula. X1 bar minus X2 bar, which means the sample size, the sample mean for sample 1 and sample 2. And mu1 minus mu2 most of the time is 0. And then I need to find S square for population. Now we need to go step by step. First of all, I need to find out the average and standard deviation for the samples. So average and standard deviation. Let's find the average for fruit punch. So I just put average. I can go here, average, and hit enter. And then the average for the lemonade, I can just copy and paste. I need to reduce the decimals, so only 2 decimals will be enough. So 134.23 and 126.46. So let's enter those numbers. 134.23 for sample 1 and 126.45 for sample 2. You can see the sample size for population 1 sample is 13, which is fruit punch, and for lemonade is 11. Now I need to find the standard deviation. Standard deviation. So I do the same thing. So I go to function stdev for this data. And then the decimals should be only 2 decimals. And I do also for lemonade standard deviation for this data here for lemonade. Again, I reduce the decimals to 2. So 2184 for fruit punch and 2998 for lemonade. Level of significance is 0.03. So we are looking for the difference between fruit punch and lemonade. So the difference is 0. Our starting point is the difference is 0. So we have the critical values. Now we need to find the t values. So in order to find the t value, first of all we need to find the S square for population. So how do we find S square for population? We call this pooled variance. So we're going to use this formula here, and then I'm going to keep this on cell B17. N1 minus 1. N1 is the sample size, which is sample size 1, B7 minus 1, times B9, which is standard deviation of the first sample square, plus this time the second sample size B11 minus 1, which is 11 minus 1, times standard deviation of the second sample square, which is B13 square, divided by B16. Remember, B16 is total degree of freedom, which means 13 minus 1 plus 11 minus 1, which is 22. And this is B16. So pooled variance is 668.8323. I'm going to keep this for my main formula for here. So T statistics, B8 minus B12. So B8 is the sample mean, first sample mean, fruit punch, minus second sample mean, which is 126.45. This is for lemonade. And minus B4, the difference. Again, the difference most of the time, if it doesn't say on the problem, it's all 0. Divided by SQRT, square root of pooled variance, which is B17, times 1 divided by sample size 1, B7, plus 1 divided by sample size 2. So at the end of the calculation, I can say the t-test value is 0.734, which is between these two numbers, is somewhere close to zero, positive, on the positive side, close to zero, which tells me there is no difference in terms of the calories between fruit punch and lemonade. So I can tell 97% because alpha is 3%. I can tell with 97% confidence there is no difference between fruit punch and lemonade in terms of calories.